You pick up your phone for 10 seconds just to check one thing. 40 minutes later, you surface blinking with no memory of the scroll between then and now. You tell yourself you have no willpower. You tell yourself you're addicted to your phone. But the real answer is far stranger. Your phone isn't the problem. Your brain is doing exactly what it was built to do 200,000 years before screens existed. Think about what scrolling actually feels like. Swipe. Nothing interesting. Swipe. Nothing interesting. Swipe. Something funny. Swipe, swipe, swipe. Something upsetting. Swipe, swipe. Something that stops you cold. That uneven rhythm. Boring, boring, boring. Jackpot. Isn't an accident of bad app design. It's the oldest survival pattern your species has ever run. And once you understand it, you'll never look at your phone the same way again. To understand why, you have to go back. Not to the invention of social media, not even to television. You have to go back to the open grassland, long before agriculture, long before villages, when your ancestors spent nearly every waking hour looking for food they could not yet see. A hunter-gatherer didn't know where the next meal was hiding, maybe behind that ridge, maybe under that rock, maybe nowhere at all. Anthropologist Frank Marlowe spent years living alongside the Hadza, one of the last populations on Earth who still foraged the way humans did for most of human history. What he documented was a rhythm of searching that looks almost exactly like a finger on a screen. Walk, nothing, dig, nothing. Walk berries. The food wasn't constant, it was unpredictable, and that unpredictability turns out to be the whole point. Here's the part that should surprise you. A brain that gets rewarded every single time it searches gets bored fast. But a brain that sometimes gets rewarded and sometimes doesn't almost never stops looking. Uncertainty is what keeps you searching, not the reward itself. Why would not knowing be more powerful than knowing? This isn't a guess, it's one of the most replicated findings in the history of psychology. In the 1950s, a researcher named B.F. Skinner ran an experiment with pigeons that quietly reshaped how scientists understand behavior. He gave one group of pigeons a food pellet every single time they pressed a lever. Predictable, reliable. Those pigeons pecked when they were hungry and stopped the moment they weren't. Simple, almost boring behavior. Then he changed the rules for a second group. Sometimes the lever delivered food, sometimes it gave nothing at all, no pattern they could detect, no way to know which peck would pay off and which one wouldn't. Those pigeons didn't peck less, they pecked more, faster, longer, almost compulsively. And here's the detail that surprised even Skinner. When he stopped delivering food completely to both groups, the pigeons who had always been rewarded gave up quickly. But the pigeons who had been rewarded unpredictably kept pecking for a remarkably long time. Hundreds of pecks, chasing a payoff that was no longer coming. Skinner called this pattern a variable ratio reinforcement schedule. You already know it by a more familiar name. It's the exact mechanism behind every slot machine ever built, but why would an unpredictable reward grip a brain harder than a guaranteed one? That question wasn't fully answered until decades later, when scientists could finally watch the brain respond to reward in real time, neuron by neuron. In the 1990s, a neuroscientist named Wolfram Schultz was recording from dopamine neurons in monkeys, tracking exactly when those neurons fired before and after a reward arrived. The assumption at the time was simple. Dopamine is the brain's pleasure chemical. It fires when something good happens. That assumption turned out to be only half right, and the other half changes everything. Schultz found that dopamine doesn't fire most strongly when the reward arrives. It fires most strongly in the gap of not knowing whether it will, the anticipation, the maybe. When an outcome became fully predictable, the dopamine response shrank almost to nothing, even though the reward itself hadn't changed at all. But when the outcome stayed uncertain, the dopamine response stayed high, trial after trial, refusing to fade. Your brain, it turns out, isn't built to chase pleasure. It's built to chase the question mark sitting just in front of it. Decades later, a researcher studying a very different kind of human behavior found the same pattern hiding in plain sight. Natasha Dow-Scholl spent years inside casinos studying how slot machine design shapes the people who play them. What she found wasn't a story about greed or bad luck. It was a story about engineering uncertainty so precisely that players described entering something close to a trance, a state where time disappeared and the only thing that existed was the next pull, the next maybe. The machines weren't selling jackpots, they were selling the gap right before one. Now hold that idea next to the Hadza, walking for hours not knowing what waits over the next ridge. Hold it next to Skinner's pigeons, pecking a lever that might or might not feed them. Hold it next to Schultz's gamblers, pulling a lever that might or might not pay. And now hold it next to your own thumb, hovering over a screen, swiping into a feed that might be boring or might be the funniest thing you've seen all week. Same circuitry, same gap, same maybe, dressed in a different costume each time. It helps to picture what your ancestors were actually optimizing for, because it wasn't comfort and it wasn't certainty. A forager who only walked toward guaranteed food would starve, because guaranteed food is rare in the wild. A forager who kept walking toward maybe, who treated uncertainty itself as a signal worth chasing, found far more calories over a lifetime than one who gave up the moment an outcome looked unclear. Natural selection wasn't rewarding patience, it was rewarding restlessness. The genes that survived were the ones attached to brains that couldn't quite sit still with not knowing. Brains that needed to check just one more ridge, just one more bush, just one more swipe. This restlessness shows up far beyond the search for food. Watch a toddler with a closed box and you'll see the same circuitry running with nothing at stake but curiosity. The child doesn't know what's inside. That alone is enough to make the box more interesting than almost anything else in the room. Open it, and the fascination often fades within seconds because the maybe has resolved into a known thing. Researchers studying curiosity have repeatedly found this same shape. Interest peaks right at the edge of uncertainty, not after it's been resolved. You were drawn to mystery long before you were ever drawn to phones. The phones simply learned to manufacture mystery on demand, at a scale and a speed nothing in your evolutionary past ever had to compete with. Here's the counterintuitive twist most people miss entirely. You assume an app is exploiting a weakness in your brain. That's only partly true. What it's actually doing is recreating the exact reward structure your brain evolved to find irresistible, then running that structure without the part of the environment that used to make it stop. In the wild, foraging had a built-in ceiling. Your ancestors got tired, darkness fell, food once found was eaten, and hunger temporarily ended the search until the body needed fuel again. The variable reward loop had natural off switches built directly into the landscape itself. You couldn't forage forever. Eventually the ridgeline ran out, or your legs did. A phone has none of those off switches. The walk never ends. The sun never sets inside a feed. There is no point of fullness because the reward was never really the content in front of you. The reward was always the next maybe. And there is always another maybe sitting one swipe away, manufactured by people who, whether or not they ever read a page of Skinner, rediscovered his pigeon's liver and quietly built it into glass. Consider how deliberately the uncertainty is engineered. A pull to refresh gesture doesn't need a half-second delay before new content appears. Engineers could make the feed update instantly, but an instant update removes the gap, and the gap is the entire mechanism. That small pause, that little spinning circle, recreates the exact moment Schultz found firing hardest in a monkey's brain, the space between the action and the unknown outcome. It is the lever rebuilt as a loading icon. The same logic shapes the order content appears in. A feed sorted purely by time would be predictable, and predictability is the one thing this whole system cannot afford because predictability is what makes dopamine stop firing. This is also why telling yourself to simply use more willpower almost never works. Willpower was never the variable being tested in any of these experiments. Uncertainty was. You are not weak for getting pulled back in after telling yourself you'd only check for a second. You are running software that is, give or take a few thousand generations, nearly identical to the one that kept your ancestors alive when the next meal was never guaranteed. The mechanism that once sent a hungry forager over one more ridge now sends a full, comfortable, well-rested person into one more scroll. The hunger isn't for food anymore. It's for resolution, for finding out what comes next. So what do you actually do with this, now that you can see what's running underneath the urge? You cannot out-willpower a system shaped by millions of years of selection pressure, but you can change the variable the system is actually responding to. Remember, predictable rewards lose their grip quickly, while unpredictable ones almost never do. So the goal isn't to fight the scroll head-on, white-knuckling your way through every urge. The goal is to remove the uncertainty before your thumb ever gets there. An app that shows the same handful of notifications in a fixed, boring order stops pulling at you the way a shuffled infinite feed does, because predictability is precisely what your dopamine system tunes out. Turning off notifications doesn't reduce temptation by a small amount. It dismantles the variable reward schedule itself, the same way Skinner's pigeons lost interest the moment every single peck became predictable again. There's something almost comforting in this if you let it sit for a moment. You were never broken. You were never uniquely undisciplined, scrolling while everyone else seems to have it figured out. You inherited a search engine that kept your entire species alive across ice ages, droughts, and migrations spanning continents by making the not knowing feel almost as good as finding something. That system worked. It worked so well that it is still running today, word for word, in a body that no longer has to forage for a single calorie to survive. The tragedy isn't that your brain is flawed. The tragedy is that the very mechanism built to help you survive scarcity now has nothing left to search for except more scrolling, in a world of total abundance, with every natural off switch quietly removed. So tonight, when you pick up your phone for 10 seconds, just to check one thing, pay attention to the half-second right before you swipe, that tiny flicker of not knowing what's coming next. That isn't boredom asking to be filled. That's 200,000 years of foraging, still walking, still searching, still certain that something is waiting just over the next ridge.